When you think about a heart attack, you probably picture this sudden, dramatic, out of nowhere event, right? But what if I told you it's not really like that at all? What if a heart attack is actually just the explosive final chapter of a story that's been quietly unfolding inside our bodies for years?
Right. Let's dive into this. While the experience, the actual event of a heart attack, is absolutely sudden, it's a massive medical emergency. The story behind it is so much longer. It's a much slower tale. So, how do we get from feeling perfectly fine one day to having a life threatening crisis the next? That's exactly what we're going to unpack. So, our story doesn't start in the chaos of an emergency room with sirens blaring. Nope. It starts decades earlier with this slow, silent process. This is Act 1, the development of something called coronary artery disease, or CAD for short.
So, what in the world is CAD? Well, at the end of the day, it's basically a plumbing problem. Think of your coronary arteries as the pipes that supply your heart muscle with all the oxygen rich blood it needs to work. CAD is the disease process that slowly, gradually starts to clog those pipes up.
So, how does this clogging actually happen? Well, it's a process called atherosclerosis, and it all starts with a little bit of damage to the smooth inner lining of the artery, like a tiny crack in the pipe. When that happens, the bad cholesterol, LDL, that's floating around in your blood can seep into the artery wall. Over many, many years, your body tries to patch this up by forming what we call a plaque. It's kind of like a little mound of cholesterol and cells with a hard, fibrous cap on top to keep it all contained. And here is the absolute key. For a really long time, we're talking years, even decades, this plaque can just sit there. It might make the artery a little narrower, sure, but often not enough to cause any symptoms at all. The cap is stable, the situation is chronic, and you can be totally unaware that this low burn is happening inside your arteries. Until one day it ruptures. That stable plaque, after all those years of silence, just suddenly breaks open. And this single moment, this is the turning point of the entire story. This is when that slow burn ignites into a raging fire. And that rupture brings us straight to Act 2. It triggers this immediate, catastrophic chain of events. We have now officially shifted from the long-term, chronic problem of coronary artery disease to the immediate crisis known as acute coronary syndrome, or ACS. So ACS is basically the umbrella term for the heart attack itself. This isn't about that slow narrowing anymore. Nope. This is about a sudden, severe blockage. It's a supply crisis where the heart muscle is abruptly starved of the oxygen it desperately needs to survive. So what's happening in these critical seconds? Well, it's a cascade. First, that rupture exposes the fatty, gunk-filled core of the plaque. Your body sees this as a major injury and sends in the emergency crews, these little things called platelets. They rush to the scene and immediately trigger a response to form a blood clot, or a thrombus, right on top of that ruptured plaque. And that clot, that's what causes the blockage and leads to ischemia, which is just the medical term for the heart muscle literally starving for oxygen. Okay, this slide really puts the two sides of our story into perspective. On one hand, you've got CAD. It's chronic, it's slow, and it might cause issues only when your heart is working hard, like during exercise. We call that demand ischemia. Your heart demands more blood than the narrowed pipe can supply. But on the right, you've got ACS. That's the sudden crisis from a clot that causes supply ischemia, cutting off the blood supply even when you're just sitting on the couch. One is the long backstory, the other is the explosive climax. But wait, the story gets even more detailed. It turns out that this one event, the formation of that blood clot, doesn't always lead to the exact same outcome. It can actually take one of three different paths, which all fall under what we call the ACS spectrum. And that's a fantastic question, right? You're probably thinking, if the trigger is the same, a ruptured plaque, why isn't the result always the same? Well, the answer, as we're about to see, comes down to one critical factor. Just how big is that blood clot? So these are the three distinct emergencies that fall under that ACS umbrella: unstable angina, NSTEMI, and STEMI. Now, I know they sound complicated, but just think of them as a gradient of severity, from a pretty bad situation to a really, really bad one, all stemming from that same initial plaque rupture. Okay, this slide right here is the key to everything. Let's break it down. First, look at unstable angina. The clot is small, it doesn't fully block the artery. You get chest pain from the lack of oxygen, but no permanent heart muscle has died. Now move to an NSTEMI.
Here, the clot is bigger, causing a partial blockage. It's bad enough that a small layer of heart muscle actually dies, and we can see that by detecting certain proteins called biomarkers in the blood. And finally, the STEMI. This is the big one. The clot completely blocks the artery. The entire thickness of the heart wall is starving and dying. This causes huge, very specific changes on an ECG and a massive spike in those biomarkers. See, the size of the clot directly determines how bad the heart attack is. All right, so let's zoom back out and put all these pieces together. Let's connect that long, slow beginning with the sudden, dramatic end and see the whole story. This timeline says it all, doesn't it? It takes years for that plaque to slowly build up. It takes just seconds for that plaque to rupture and trigger a clot, and then it takes only minutes to hours for that clot to cause irreversible damage to the heart, defining exactly what kind of heart attack a person is having.
So here's the main takeaway, the most important point of all of this. The sudden, life-changing event we call a heart attack is not some random bolt from the blue. It's the predictable result of a disease process that's been smoldering away for a very, very long time. The crisis is simply the final act of that slow burn. And that leaves us with one last big thought. If the crisis is just the endpoint of a decades-long process, it changes how you think about everything. The real fight against a sudden heart attack doesn't just happen in the emergency room. It begins years, even decades earlier, during that long, silent phase of the slow burn.